Hey everyone, today we're going to be going over J194a, problem 1. So, given that x is greater than y, we have to prove that x plus y over 2 is greater than 2x plus 3y over 5. So what I'm going to do is I'm going to rewrite this inequality because we can move things on two sides of or move things in like an expression. So I'm going to move this to the left hand side of the equation, and by doing that I'll get x plus y over 2 minus 2x plus 3y over 5. That is going to be greater than, well, if I move this to the left hand side of the equation, this is just going to be equal to 0. So I have to prove that this is true now, given that x is greater than y. And if I can prove that this is true, this is the exact same thing as essentially this, just rearranged. So I want to prove this. So how can I prove this? Well, I'm going to go ahead and combine or subtract these fractions. So I'm going to get a common denominator of 10. So I'll multiply this entire fraction by 5 over 5. And then I'll multiply this fraction by 2 over 2 to get a common denominator of 10. And now I'll get 5 times x plus y minus 2 times 2x plus 3y. That's all going to be over one fraction, 10. One denominator, 10, is greater than 0. If I multiply everything out, I'll get 5x minus 5y minus 4x minus 6y over 10. That's greater than 0. And that's going to give me x. Sorry, this was plus y, sorry. I realized that this should be plus y. Yeah. I will get x minus y over 10 is greater than 0. And if I can prove that this is true, then I can prove that this original expression is also true. Well, in the problem, they tell us that given x is greater than y, so if x is greater than y, that this means this, if x is greater than y, a bigger number minus a smaller number is always going to give you, I guess, like a positive number, right? Yeah. So we know that x minus y is greater than 0, which means that if you have regardless of how small this number is, it's always going to be greater than 0, right? Say we have x is 2 and y is 1.999, then x minus y is still going to be 0.00 1, right? But it's still going to be positive. So regardless of what number you have up here, as long as it's positive, a positive number, I'll just write a positive sign for positive, divided by 10 is always going to be greater than 0, because a positive divided by a positive number, another positive number, is always going to be greater than 0. And yeah, that effectively proves that this original inequality is true. So, but now I guess you can write it in formal words if you want to say it, because that's usually proofs you write it out formally, the proofs. So since this is true, that means that therefore, this is the therefore sign, therefore this was true. So this is what we got by rearranging the inequality all onto one side, moved everything to one side. Since this is true, we prove that this is true, and therefore the final answer, we know that the original inequality was also true. Is true. And yeah, that's essentially the proof that you want to kind of show. And yeah, that's it for the problem. Alright, good luck. Bye bye.